Messi was banned from TikTok. Why? To answer that, you need to see what a single selfie from a superstar like Messi does to the internet. Because here's the thing. Inside every big tech company, there are engineers who are genuinely nervous about accounts like Messi's. Not because of anything he says, because of what 500 million followers does to their servers. In the next few minutes, 6 ways one Messi selfie can break a social platform, and the exact fix big tech uses for each one. Let's go. Problem 1. The fan-out problem. Start with how a feed actually works. Every user has a mailbox. When your friend posts, the system copies that post into the mailbox of every follower, immediately, before anyone asks. 300 followers, 300 copies, done in milliseconds. So when you open the app, your feed is already sitting there. Instant. This is called fan-out on write. Now Messi posts one selfie, 500 million mailboxes. Say your system writes 10,000 copies a second. That's fast. 500 million divided by 10,000, 14 hours, to deliver one photo. And while the workers grind through Messi's list, everyone else's posts are stuck in the queue behind him. Your friend's wedding photos? Number 400 million and 2 in line. One selfie just lagged the entire platform. The fix, the hybrid model. Normal users keep their mailboxes, but celebrities get a billboard instead. Their post is stored exactly once, no copies. When you open your app, the system grabs your mailbox and glances at the billboards of the celebrities you follow, merges the two, and hands you one feed. That merge is called fan out on read. The rule: small accounts push the post to readers. Huge accounts let readers come to the post. Elegant. Except we just traded a write problem for a read problem, because now 500 million people are all reading the same single record. Problem 2. The hotkey problem. First, understand how databases scale in the first place. When your data gets too big for one machine, you split it. This is called sharding. Half your user's data on storage 1, half on storage 2. At real scale, 1,000 machines. Think of a warehouse with 1,000 shelves. Every user gets assigned a random single shelf, so every shelf carries an equal weight, spreading the load evenly. That's the entire trick behind web scale. By the way, if you want to know more, I've linked a short in the description. Now spot the flaw. Messi's post is one record. It landed on one random shelf. And all 500 million reads are asking for that exact record, so they all converge on that one machine, while the other 999 shelves sit idle. That's a hot shard. And the worst part, adding more servers does nothing. You can't split one record across 2 machines. The like counter is even simpler to see. 500 million people liking the same post. That's 500 million updates to the same single record. And a database only lets one update touch a record at a time. It locks it. So every like waits in one giant line for one record on one machine. Your 1,000-server cluster is now exactly as fast as one machine, period. The fix? Cheat. Split Messi's like counter into 100 subcounters on 100 machines. Each like updates a random one. Add them up when someone looks. Or batch likes in memory and flush every few seconds. Either way, that like count you're staring at, it's a deliberate estimate. Big platforms chose roughly right and alive over exactly right and dead. Problem 3. The thundering herd. Reading the same post millions of times? There's a classic answer: a cache. Keep a copy of Messi's post in a super fast memory layer right in front of the database. Now the crowd reads the copy. The database behind it barely gets touched. But there's a catch. Copies don't live forever. Every copy has a timer, and when it runs out, the copy is thrown away, so a fresh one can be made. Now watch what happens the moment Messi's timer hits 0. For one split second, there's no copy. And in that split second, 1 million requests arrive, find nothing, and every single one goes straight to the database, together. The database, built for very little traffic, takes 1 million hits at once and dies. That's the thundering herd. Nothing broke. The cache expired, right on schedule, doing its job, and that alone took down the platform. The fixes: 4 one-liners. Only one request goes to rebuild the copy. Everyone else waits at the cache. Keep serving the old copy while the new one loads behind the scenes. Give every timer a slightly random length so copies never die together. And refresh the hottest copies before their timers ever run out. Miss any one of these, and a countdown timer takes down production. Problem 4. Connections and bandwidth. Now Messi goes live. 2 new problems at the same time. First, connections. Every viewer watching keeps an open line to your servers, and every open line costs memory. Here's the catch. Your web servers can hold a lot of open lines, but your database can only handle a few thousand. A small company, a handful of servers, one load balancer, physically cannot hold millions of open lines. So big platforms use a funnel. At the front, fleets of lightweight edge servers whose only job is holding millions of cheap connections. Behind them, those millions get squeezed into a few fat pipes to the real backend. And the same funnel repeats at the database. A connection pooler lets thousands of app requests take turns sharing just 50 real database connections. Many cheap lines in front, few expensive lines behind. That's the pattern at every layer. Second, bandwidth. 10 million viewers, each pulling 5 megabits per second. Multiply it. 50 terabits every second. That's not a big server bill. That's physically impossible to send from one building. The fix is a relay tree. Messi streams once to one ingest server. That server feeds a handful of regional relays. Each relay feeds thousands of edge servers around the world. Each edge server feeds the viewers near it. One stream becomes 10 million, doubling and doubling down the tree. And no single machine ever carries the full weight. It's also why your live stream runs a few seconds behind real life. Those seconds are the trip down the tree. Problem 5. The notification bomb. One more trap, self-inflicted. Messi just posted, pushed to 500 million phones. That one notification triggers the spike. Everyone opens the app in the same 60 seconds. You just scheduled your own stampede. The fix: platforms deliberately deliver notifications slowly, spread out over a few minutes to flatten the spike. So when Messi's notification arrives late, that's not lag. That's the platform protecting itself from you. Problem 6. The cost problem. Last one. Even if you nail every fix, celebrity traffic means building for 100 times your normal load, that you need maybe 1% of the time. And auto-scaling can't save you. New servers take minutes to boot. The Messi spike peaks in seconds. So big platforms pre-warm capacity before big events, overbuild the hot paths, and run drills where they break their own systems on purpose, chaos engineering, plus around-the-clock teams watching dashboards. And here's how real this is. The World Cup final is about to happen. If Messi lifts that trophy, his post will be the most liked thing on the internet within hours. Last time, in 2022, it broke Instagram's all-time record. So right now, engineers at Instagram and TikTok are already adding extra servers, warming up caches, and preparing for that exact spike, before a single goal is scored. Big companies can afford all that. A small startup can't. It's a handful of engineers, and when the spike hits, one of them wakes up at 3 in the morning to a crashing system. So, was Messi banned from TikTok? No, never happened. But the fear behind the rumor is completely real. It even has a name. Engineers call it the celebrity problem. Twitter had to redesign its entire timeline system because of accounts this big. Every major platform today literally runs 2 feed architectures side by side, one for you, one for the famous, with code deciding who's too popular for the normal path. TikTok can handle a Messi. They've had the outages, learned the lessons, built the machinery. But a small platform with a small team, every one of these problems may hit them one day. That's the real story. A follower count isn't just a number on a profile, it's load. And at 500 million, a selfie is a stress test most of the internet would fail. If this clicked, subscribe. On this channel, we break down every one of these engineering design problems one by one and get you ready for the system design interview. You already know more than most people who walk into that room.